In this video, we're working on the Module 4 test review. So question 10 says, a jogger begins her workout by jogging to the park, a distance of 35 miles. She then jogs home at the same speed, but along a different route. The return trip is 42 miles, and her time home is 1 hour longer. Find her jogging speed. Let R be the jogging speed. So with each word problem, the first thing you need to do is organize the information in a way that makes sense, that is usable. Because right now there's a lot of information given, but we don't know which information is important and which information is not important. So I'm sure you've seen the distance equals rate times time chart, right? And we have to the park and home from the park, okay? Also, I find it's helpful to draw a picture. So she left her house and she jogged to the park, right? And then she came home on a different, longer route. So the distance to the park was 35 miles, right? It tells us here. And then the return trip was 42 miles, right? And then they tell her that her time is 1 hour longer, right, on the way home, right? So it took her an hour longer to get home. That's saying that if her trip to the park took 2 hours, then it took her 3 hours to get home. Okay, so I want you to think about it in that sense. We don't know that it was 2 hours and 3 hours, but we need to think about it in that way, that the trip to the park was 2 hours or whatever it was, and the trip home already took 3 hours, okay? So we know the distance to the park was 35, and we know the distance home was 42. Those were her two distances that she jogged. It says, let R be the jogging speed. So please make sure you're paying attention to that. If it's on my math lab and it asks you to fill in a chart or something like that and it tells you to use a certain letter, you need to use that letter. Normally you could use X or whatever you wanted, but since it specifically tells us to use R, we should. So we know that her rate was the same because see here it says that she was on the same speed. Even though one was longer, so it took more time, the speed was the same, okay? So they're both rate. And then the connection that we know is that the times are not equal, right? Like we were used to, but the time home takes 1 hour longer. So what we're actually going to do is add 1 to the first half. We're going to add 1 hour to the trip to the park. Because remember I said, let's pretend that this trip took her 2 hours and this trip took her 3 hours. We don't know that, we're just using figures. To make these equal, we would add 1 to the trip to the park and then they would be the same. So that's the same idea we need to use when we're setting up our equations. Okay, so the actual time would be 35 over R, right? Because distance equals rate times time. So if we solve for time, we divide by the rate. Time equals distance over the rate. So 35 over R and 42 over R. And then what we're saying is that this whole time needs 1 more added to it. That will make these two equal. 35 over R plus 1 equals 42 over R, lowercase r. Okay, so because we're saying the time to the park plus 1 is equal to the time home because the time home was already 1 hour longer. You could also do minus 1 on the time home and not add 1 to the time to the park, and that should work also. So now we're going to go back to kind of what we were doing in the previous video where we want to eliminate our fraction. We want to look for an LCD. There's two fractions and then a whole number. So the two fractions actually have the same denominator, which means our LCD is just R. And then what we want to do is we want to multiply each term by R. this will eliminate our fractions for us, right? So we're going to multiply this by r, this by r, and this by r. So you see, we get r over r. They cancel out. I just have 35. R times 1 would be plus r, and then equals, the r's cancel out here, 42. Subtract 35 from each side. R equals 7 miles per hour. Remember, because r was our rate. It was the jogging speed, so it should be 7 miles per hour. And that's a reasonable speed, right? I mean, I can't run that fast, but some people can. Okay, so now we have a plane that flies 405 miles with the wind and 315 miles against the wind in the same amount of time. If the speed of the wind is 20 miles per hour, find the speed of the plane in still air. So again, we have one plane that can go 405 miles and one plane that went 315 miles. But we know that they were going the same length of time, and then the wind is going 20 miles per hour. So they're both in the same wind. So now we're going to set up our chart. Distance equals rate times time, right? And they really don't tell us a lot about the planes, so we're just going to say plane 1 and plane 2. Right? There's two planes. The distance of the first plane was 405. The distance of the second plane was 315. Same length of time. So again, time equals distance over rate. Okay? So our rate is where we're not sure. We don't know how fast the planes were flying. We know that the wind was going 20 miles per hour. Okay? So now's where most people get confused. They say, is it r plus 20 or 20 plus r? R plus 20 says I'm going at a certain speed and the wind is pushing me faster. 20 plus r is saying the wind is going at a certain speed and I'm making the wind faster. So we do not want to write 20 plus r, because that's saying that I'm going to change the wind speed. I'm going to make it go faster or slow it down. And that's not the case. The wind is either going to push me faster or slow me down. Okay? So I have r plus 20, and then the 315 miles is going against the wind. So r minus 20. The wind is slowing it down. That's why they went less distance. So 405 over r plus 20 and 315 over r minus 20. We know it's the same length of time, so we can just literally take our times. 405 over r plus 20 equals 315 over r minus 20. And now we can solve. And this one we actually don't have to get an LCD because it's a proportion, so we can just cross multiply when it's one fraction equals another fraction. So 315 times r plus 20 equals 405 times r minus 20. Okay, so now we need to distribute both of these into the parentheses. So we get 315r plus 6,300 equals 405r minus 8,100. Okay, now we just solve for r minus 315r minus 315r. Right, gives us 6,300 equals 90r minus 8,100 plus 8,100 to both sides. So I get 14,400 equals 90r. Okay, so then we divide by 90 and divide by 90. You get r equals 160 miles per hour. And if you remember, we were talking about the speed of the plane in still air. So the wind is either speeding it up or slowing it down. So 160 miles per hour for a plane is a reasonable speed, right? All right, so looking at solve the absolute value of the equation. And I'm going to go back and just talk about the definition of absolute value real quick. So when you're talking about absolute value, you're talking about a number's distance on a number line from 0. So if you look from 0 to 3, it's 3 away from 0. Everybody agree? Likewise, -3 from 0 is 1, 2, 3 away from 0. It is talking about a distance, and that is why an absolute value can never be negative. You can't have a negative distance. You can only have a positive distance. So, again, first thing we need to check is that an absolute value, whatever's inside, is not equal to a negative number, right? It can never be equal to a negative number. You can't have a negative distance. So looking at this one, we're good. We have 9z plus 8 plus 10 equals 3, right? So the first thing we need to do is get the absolute value equals something else. Minus 10 minus 10, I get 9z plus 8 equals a -7, okay? So hopefully you're saying, wait, an absolute value cannot equal a negative number. Exactly. Right now, before we had an absolute value plus something equals a positive number. So it looked like it was going to be okay. But once we moved this 10, now we got an absolute value equals a negative number. An absolute value is a distance. So it cannot equal a negative. So this one would be no solution because we got an absolute value equals a negative number, which is not okay, right? So here's another one. Solve the absolute value equation. We have absolute value 6 plus 4b minus 19 equals -2. Okay, so don't let this one fool you because still we have this number. It's equal to a negative, which may be a problem, but we need to move this 19 first because what the rule says is that an absolute value, so the part that's in the bars, cannot equal a negative number. And right now we have this extra number. So first we need to say plus 19 to both sides, which gives us 6 plus 4b equals to a positive 17, which is okay, right? Because now we're equal, an absolute value is equaling something positive, not a negative. Also, not to be confused with that my answers, my b, could be a negative number, and that's okay. I just cannot get the actual absolute value equals a negative number because that would imply a negative distance, and that's not okay. So, now we have to go to 6 plus 4b equals 17, or 6 plus 4b equals -17, because the nature of the absolute value says that when I put something inside of the absolute value, so if I put 4 in the absolute value, it gives me 4. But likewise, if I put -4 in, it also gives me 4, because it's saying, the absolute value is saying, what is the distance from 0 on a number line? And we talked about with 3 that 4 is 4 units away, and -4 is also 4 units away. So we have to then, when we're solving, incorporate both the positive and the negative, right? So now we need to solve both of these equations. So minus 6 gives me 4b equals 11, divide by 4. My math lab does not like decimals or anything like that, so I would leave it as 11 over 4. You probably could go to a mixed number, but it's not necessary. And then this one, minus 6 gives us 4b equals a -23. And divide by 4, so b equals a -23 over 4. Again, I can have a negative b because if I plugged that in, once I put it into the absolute value, it's going to give me a positive. So it's okay that one of my answers is negative as long as it's not equal to a negative. If it was equal to a negative, that's where the problem lies. So this answer is the set of 11 over 4 and negative 23 over 4. Again, leave them as fractions. Don't go to decimals. You could go to a mixed number, but if you make a mistake going to a mixed number, then you're going to lose points because now you did something wrong versus just leaving as an improper fraction.